So without further ado, let's get into it. My name is Kedaar. I'm joined by Mithil, Atharv, and Ansh. We were advised by Suresh Subramaniam, and our project is predicting YouTube virality using video content. Let's dive into the problem and why we're trying to solve it. For one, companies and individual creators are really struggling, and it's for a ton of reasons. First, it's really hard to identify what topics will work and what topics won't. And it's difficult to get feedback, especially when you're an independent creator, because you're independent. You don't have a lot of people you're working for yourself. And it's really costly if you produce a low performance video. What do I mean by that? Well, if you spend a lot of money on props and resources and try to make sure that your YouTube channel can get burgeoning success through viral videos, and it turns out to flop, well, you've lost a ton of money, a ton of time, and you haven't progressed anywhere. Along with this, it's also extremely tedious to analyze these high performance videos you see on trending pages, because a lot of them come from similar channels and some are viral for no apparent reason. At least for now, our product will solve that. And finally, niche audiences are really hard to cater to because sometimes you don't know your audience as well as you think. Now, adding on to this, some past models were built on, video, metadata, titles, descriptions, tags that you would use for SEO or search engine optimization, making sure that your product or your website or your video shows up on search engines. But our model is based on actual video content. It takes in transcripts, it takes in images, it takes in videos, and it actually shows what viewers would think gains value. It would help them gain value. And that's obviously what a creator is trying to achieve. Now, Mithil will talk more about how we source our data.
So for our start, we decided to start off small, of course, because we needed to prove that this concept will actually work, that we can study the content and predict virality. So we started with transcripts, as images and videos are harder to analyze, but in the future, we do plan to get there. Now, when picking our videos, when we analyze text, we basically create like a dictionary of all the words that are used in the documents, in all the transcripts. So we didn't think that it would make sense to combine words from like the gaming genre and words from the fashion genre, because it would really confuse our model. So we decided that we need to pick a specific genre. So we decided to do politics and news. It's a default YouTube category, so it was easier for us to source it from there, and we could automate that sampling process. And another reason we chose politics and news was because we could really like get a feel for what this model was doing, like how was it using what we know to be popular in its decisions. So then following that, we sampled around 24 channels and we sampled up to 50 videos from each of those channels. The full list is on the bottom. And we couldn't just take any sort of video, because of course you can't compare a 30-second video with maybe a couple of words to a long form full-hour documentary, because the number of words and the differences in the words are going to be different. So we can't compare those two. So we decided to only study videos and only sample videos between 4 and 15 minutes. And then again, another constraint we had was you can't compare the views of a video from yesterday versus a video that was released a year ago, because of course, more often than not, the video from a year ago will have more views. And our decision factor in our model was that if it's viral, then it has more views. If it has more views, then it's more viral. So of course, our model would consistently say that the video from last year was more viral. So we didn't want to introduce another conflicting variable. So we removed that by only selecting videos from 3 to 5 months ago. Now, the data that we get is in the form of text, right? It's all transcripts, and computers and models don't understand text. So that's why we have to convert this text into numbers, and we call that process vectorization. There's a lot of different ways to vectorize text. And for example, some of them are just taking the number of words, like the most popular words, and that's known as using a count vectorizer. We decided to use a TF-IDF vectorizer, which uses it's a formula. It's a pretty complicated formula, but what it does is it gives each word a value. It tries to give each word a value based on its relevance to that document. And as you'll see on the next slide, like you can see on the next slide, which words that the model found were the most popular by count and which words were the most relevant by TF-IDF value. So on the left is the most popular words by count, and on the right are the most popular words by TF-IDF value. So the right one is, and we trained our model based on the values on the right side, like the relevance to the document, which is common in the field. And now Atharv is going to talk about how we use this data to train and build a model.
All right, so now that we had all the vectorized text in the form of these TF-IDF values, it was time for us to actually start training our model to predict which video was going to be viral and which one was not. So we took the vectorized text that we had, and using that, we trained a random forest classifier model. And before we did that, we needed to place our data into 3 tiers of virality, basically just labeling the data to show the model, this video is this amount of viral, this video is this amount of viral. So we put it in 3 different tiers. And the first one was 0 to 22,549 views. Second one was 22,450 to 140,361 views. And the one after that was 143,620 views and more. And remember, news channels turn out videos every hour. So this would, we would have enough videos to keep doing this. After training the model, we tested it on data from other news channels, and our initial accuracy was 62%. We tweaked it a bit, we made some adjustments, and towards the end, we got it to like 69% accuracy. And now this is just from using the transcript. And I think Mithil mentioned in the beginning that we're planning to add more things to this too. So in the future, we plan to use factors other than the transcript, expand to other video genres so that this becomes applicable in every field and can help people that are not just news channels. And yeah, that's it. Now Ansh will talk about future improvements.
Yeah, so here's some more future improvements. Some more improvements that are needed for our model is that one of the news channels that we used was CNN, and a lot of the CNN data files were full of made-up words or complete gibberish, which needs to be removed from our data set. And we can do this by updating our cleaning script and removing the CNN data files, which are just filled with gibberish. Some next steps for our model is that we can try different models besides the random forest classifier. There's the OpenAI GPT-3 model. There's a Google BERT model. And this has a chance of getting the accuracy up from 69% to even higher. And we're going to try using models for other types of videos and not just news. So some of these types of videos can be vlogs or gaming videos or basically any other genre that's on YouTube. So far, our project was just on news channels, but we can expand this to obviously other YouTube genres. We can publish our findings to research journals. 2 of these are the Journal of Research High School and the Journal of Emerging Investigators. This could take a while, but this is definitely a goal that we may want to look at. Next, we have our sources. So our sources were the YouTube data API that we used. We also used the YouTube transcript API, and we used videos from 24 YouTube channels. The YouTube channels that we used are listed on the right, and this is a picture of our data set. So we would also like to thank ASDRP for giving us the opportunity to do this project, and we would also like to thank Mr. Subramaniam, who guided us along the way throughout this project. Thank you.
Nice job. Very nice job. Any 1 or 2 questions for the group before we move on to our next one?
Maybe you can answer it in the chat. I don't want to take time. Did you try to use boosting instead of random forest? And your false positive rate is pretty high. So how you're going to tackle that? Like apart from cleaning, do you have any other strategy? You can send it a reply in the chat, not to take anyone's time.
That's a good idea, Sahar. Thanks. Good question too. That'll give them some food for thought. I like it.
Also, hi, I have a question regarding your data sources. Did you have any of high volume social media? I know you scrubbed a lot of news accounts, but you probably addressed it. What about TikTok, Instagram, and Twitter that use a lot of hashtags? Did you include it, or if you excluded it, why?
So so far we were just focusing our project on YouTube, but we can definitely look into other social media platforms such as YouTube. I'm sorry, such as TikTok and Instagram. So yeah, that's definitely a possibility going forward. But yeah.